We will first look at the example of a digital measurement, such as the reading shown by a digital scale that does not change over short time scales. In our example, we measured the mass of a steel block. We place it on the scale, and the display reads 83.4 grams. Although the scale is reading a single, unchanging value, this is still only an approximation of the mass. To see this, we ask, what if we could adjust the scale now to read the next digit? What would that next digit read? It could be anything from 0 to 9 and give a result that is consistent with our first measurement. That is, the scale could read anything from 83.35 grams up to 83.45 grams, and the result would have been rounded to 83.4. This range of possibilities indicates our probability distribution function for the uncertainty of this measurement. It is rectangular in shape, since there is equal probability for any of the results inside this range. We will label this type of measurement a rectangular PDF. So, we measure the mass again with a more precise scale, and we get 83.36 grams. Is this now the actual mass of the block? No, we're still measuring an approximate mass. But we can see that this new measurement also has a range and that it fits within our previous estimate of the mass. The width of this new range is now 0.101 grams, corresponding to the sensitivity of this new scale. We could continue this process with a scale with a sensitivity of 0.001 grams that then reads 83.363 grams. This gives us a value for our confidence interval and thus our uncertainty for a digital device. The full width of our 100% confidence interval is the smallest unit that can be measured by the device. So our uncertainty is half of this interval. The measure end is the exact center of this rectangle. The fact that it is a rectangular distribution means that it isn't really a good guess, since the measurement could be anywhere in the range with equal probability. However, by convention, we will report the center of the rectangular distribution as the measure end. Finally, we want to report a 95% confidence interval in order to match the uncertainties we've done previously. So we multiply the half width of this rectangle by 0.95. The general procedure for finding the uncertainty for a digital measurement that does not fluctuate is to 1. Find the initial estimate for the measure end from the digital reading. 2. Determine the smallest measurement digit of the instrument. 3. The uncertainty is then 0.95 times half of the smallest measurement digit. 4. Round the uncertainty to 1 or 2 significant figures. And 5. Adjust the digits in the measure end to match the uncertainty. This may involve adding significant figures. Since we are reporting the center of the rectangular PDF and not the measurement reading, this is an appropriate way to report the measurement.